Robotics. They are used in everyday industrial, military, exploration, homemaking, academic, and research applications. Robotic automation plays an increasingly important role in the global economy and in daily experience. Robots provide companies the flexibility in their production processes to meet their high demands. Over time, however, efficiencies and accuracies are lost due to the manual time and effort of robotic reprogramming. This occurs because all robots are programmed manually by a skilled workforce. Since each robot part is manufactured with variances, each robot cell installation cannot be built exactly to spec. Even the fixture platform may not be stationed correctly. With so many tolerances within each installation, an automated program was needed to revolutionize the robot programming process. That program is called the Dynalog Robot Cell Calibration System. Created by Dynalog Incorporated, the Dynalog solution eradicates any inconsistencies between the actual assembly and theoretical design of the robot cell while eliminating the need for manual teaching of each robot. This is accomplished by the usage of mathematical formulas and accurate measurements. More recently, Dynalog has enhanced the Dynalog solution by integrating the FARO measurement system. This Dynalog FARO interface is designed to be used with the FARO laser tracker. Here to demonstrate this state-of-the-art calibration solution is Dynalog's Dan Hazley.
Hi, I'm Dan Hazley with Dynalog. I'm going to show a demonstration of how we can use the laser tracker to find a random location of a plate, and then we're going to offset the robot program so the robot goes very accurately through a path that's been carved through the plate. First thing I would need to do is to change the plate location into some random new position. So I loosen this and just turn it. So now obviously it's way off from where it was before. So the next thing we have to do is measure with the laser tracker. So first I'm going to go and pick up the SMR, the probe. And I'll use this to measure 4 locations on the plate. There's a second one. That's the third one. And there's the 4th point. And now we recalibrate. We've got a very good result here. And then this program has been modified based on our calibration data. And since we have a very accurate robot from when we calibrated it before, it can run through this path now very accurately without touching the sides. And I'll show that here right now. I'm going to start up the robot, and it'll move right through the program. This demo is showing the process using the laser tracker to take the calibration measurements, and then the Dynalog software takes those numbers, that data, and can improve the accuracy of the robot. The reason we improve the accuracy of the robot cell is to mainly eliminate a lot of the manual teaching that happens at the installation of the robot. When you have an offline programming process that's being used, you can eliminate the manual touch-up that's required when trying to download those programs to the actual robot cell. Also, the program can be cloned from one robot cell to another robot cell, and we can eliminate all the manual teaching that has to happen in between that process. The reason that manual teaching has to happen is that robots by themselves are not very accurate. A standard robot will be off in its accuracy anywhere between 5 to 10 millimeters. And then there's the error between the robot base and the base of the fixture, as well as the location of the tool center point, which is also called TCP. Those 3 elements combine the accuracy, or they make up to give you the accuracy of the robot cell. And the Dynalog process calibrates all of those 3 elements in a single process. The calibration process includes 2 phases, the identification phase and then the compensation phase. During identification, we are measuring the robot, in this case with the laser tracker, and then we use that data to calculate all the parameters of the robot arm, which are, there's quite a few parameters that make up the geometry of the robot, as you can imagine. And all of those stack up one on top of the other to give you the accuracy at the end of the arm. At the end of the identification process, we will have a parameter file, which is basically a signature of the geometry and the kinematics of the robot. And we'll also have an alignment file that gives you the relationship between the base of the robot and the fixture. With those two files, then we move on to the compensation phase. The compensation phase takes the program that is generated offline using the nominal data and then corrects that program to compensate for all the actual errors that we measured during the identification phase. When we complete the compensation phase, we take the brand new robot program and we download that to the actual robot controller. And then that corrected program is what's run. In this step of the process, this is the identification step of the process, and you can see in our software we have an interface with the FARO laser tracker. In fact, the Dynalog software can control the laser tracker directly. Dynalog developed the interface with the FARO tracker using the software developers kit provided by FARO. And so with a single application, the Dynalog application, you can connect directly through an Ethernet connection to the laser tracker and take these measurements into our software. And so there's no need for any data transfer later on. It makes the process very convenient and easy to use. Once the calibration is done, our software will compute the accuracy of the robot after calibration. And in many cases, we can get the robot to be well under 1 millimeter accuracy. In fact, in quite a few cases, we're within a half a millimeter or even a quarter millimeter accuracy. So by using offline programming and the FARO tracker and the Dynalog software, this provides a total solution for end customers to do high precision robotic applications, to do very fast and accurate programming of the robot. One of the main benefits that integrators and end customers get from doing this type of a process is that they decouple or they remove the programming process from the critical path of launching a robotic system. What this means is that they can do the programming far in advance of the actual robots hitting the floor, the factory floor. Of course, when the robots are installed on the floor, the timing of this process is very critical. So if you can have all your programming done ahead of time and your robot calibration work done ahead of time, then installing the robots and getting the project up and running quickly can be done in as little time as possible.
The success of the Dynalog solution is not only due to the high accuracy of the FARO interface, but also its ease of use and versatility. For any shop floor environment at any level, the Dynalog system is the perfect choice for your robotic calibration.